folks, so our Wassell Vape electronic ignition turned up, which we're going to fit onto the Daytona. Before I put it on, I want to do a few physical tests first, just to compare what I've already got on the bike to what we're going to be fitting. I mean, I've fitted this unit, probably 4 or 5 of these now on different machines, and I'm pretty pleased with it. But I just want to do a bit of physical science so we can see what's going on. But just let's have a look to see what we've got first. So that's the unit itself. It's made out of a billet of aluminium turned up. The coils are installed, and there's the ferrous iron cores for the coils. They're then encapsulated or entabulated or whatever in a resin, and you end up with just the 2 wires, and the coils are actually connected in series. So that's the bit that goes in place of the 6CA. Then this goes in place of the advance and retard unit. So we've got our 2 revolving magnets. So they're probably neodymium, I would imagine. But what we're going to do is we're going to fit them. I mean, I made this some time ago. This is what I use for testing coils and condensers and leads and plug caps and all that junk. So this is a replication of what the timing case is like on most of the side points versions of Triumphs and BSAs. Maybe some others, I don't know, last generation matchlesses and things like that that use the same 6CA points plate. So this is obviously a recovered 6CA points plate, so you can have 1 or 2 sets of points, single or a twin. The condensers now are normally mounted somewhere else on the bike, but I just keep it like that for simplicity. Then inside we've got our bob weights and the cam, obviously, and this one will be a single because I'm turning it in that direction. Depending on whether it's a Triumph or a BSA, Triumphs have an idler gear in between the crank and the camshaft, so the camshaft turns in the same direction as the rotor. But on BSA singles and BSA twins like the 500 A7 and the 650 A65, they pick up on the intermediate gear between the crankshaft and the timing gear, so they actually turn in the opposite direction, so they go backwards to advance. So you have to be careful when you're buying these second hand, you make sure you get the right orientation. So I'm going to split this up now, and we'll drop this stuff in, which should go in. Might have to make some modifications and just see how it fits, and then we're going to do some tests. But no, let's do some tests with this first and have a look at the quality of the spark with standard 12 volt coil, standard points, and this configuration. So we'll be back in a short while. So here's our setup. The device is now in the chuck, in the lathe. There's a bit of alley plate to stop the outer body revolving. We've got our 12 volts 3 amp regulated power supply. We've got our 12 volts Lucas motorcycle coil, HT lead, unresisted cap, and whatever spark plug, who knows, but it is a new one. Put it on this latex or butyl glove or whatever it is, black surface, so we might be able to see the spark a little bit better. So let's fire it up and see what happens. So you can hear it clicking away there. So hopefully you can pick that up. The spark, maybe. See if I can turn this light out of the way. Or maybe let's pull the blind down. So I should be able to pick that spark up. So the lathe is actually, I've fitted a Jaguar Cub IMO inverter to it, and I can change the speed. So it's obviously running at camshaft speed, so I'm going to wind it up. This will be the equivalent of about 2000 RPM. So that is a very, very healthy spark, and also there's no arcing at the points, so the condenser etc. is good. So we're going to now set, let's wind that back a bit, we're now going to do the same setup now with our Wassell vape unit. So I'm just going to do it with one coil to start off with, that same coil, but later on I'm going to take the HT leads off and put two 6-volt coils in series to see if there's any difference. Oh, the other thing I'm going to try is I'm going to wind the voltage down on this with the points, just to see at what point we lose the spark. I know we'll probably lose the spark earlier inside the engine when it's under compression, but just as a matter of interest we'll wind the voltage down and see when that stops sparking, and I'll just record it on a bit of paper, the value, and I'll let you know. So let's try the Wassell stuff. Well, it fitted straight into the little unit that we've made, or I made, for testing the points etc., because it is the same cavity, if you like, as all the standard 6CA point setup machines. So it's in there, and I've wired it up, and I have given it a quick run, but I'll just show you what it looks like. So same setup. There's our regulated power supply set on 12 volts. There's the unit mounted in our little cavity setup, whatever it is. This is just a temporary, obviously, chocolate block connector, just so I'm not going to put any crimps on there or anything yet, because I've obviously got to be put on the bike. So that's just my connection for the pickups, goes straight into the little box. Then you've only got 3 wires coming out of the box. You've got negative and positive to the coil. I'm using negative ground on this one, but it works exactly the same for positive ground. So neggy posi straight out of the box into there, and the negative, separate negative, picks up off this one here onto there, but also I've piggybacked it obviously for the spark plug, because the spark plug's going to need a negative supply as well, as I'm on negative earth. So let's just get this, pull that screen down again, let's make it a little darker. How's that? So let's fire her up. So I should be able to see that. I mean, that is a lovely blue spark. I'm just going to crank it up. So what we've got running now, we're on 400 RPM camshaft speed. So that'd be 800, that'd be tick over on the bike. So That's 1000 RPM, so that would be 1000 RPM on here, 2000 on the bike. I'm just going to wind it up. That's 1500 RPM, so that'll be 3000 RPM on the bike. And actually that spark, I can actually smell the ozone off the plasma. It's that powerful. So let's knock it back down a bit. So we're running, let's run it at 1200 RPM engine speed. And what I'm going to do now is I'm going to knock the voltage down. So we're running at exactly 12 volts here. So I'm going to creep it down until she starts to go bad. So that's 10 volts, no difference. 8 volts, 7, starting to fade. That's 5 volts and it's still, you know, the bike should probably still run at that, 5 volts. 4 volts, so it disappears at 4 volts. Back at 5, 8, 10 and 12. So there's 12 and there's 10. 10, 12, 10, 12. There's no difference between the two. So you probably get away with it right down to about 7 volts. That's 7 volts now. Start to drop off from there. It probably wouldn't spark under compression. Back up to 12. And that's a lovely spark. So I'm going to turn it off or stop spinning. And I'll just quickly show you this. I'm going to turn it on and then switch it off. So when it's running, she's pulling about 2.1 amps, which is the resistance of the coil and whatever power we take in to drive the SCR and the capacitor charge, the capacitors in there, which is probably hardly negligible, nothing. When I switch this off, I'll stop this chuck from spinning. So they're 2.7 on idle, and after a second it switches off, so you're not going to overheat the coil. So I'm happy with that, but what I'm going to do now is we're going to set this up for the 2 coils. So the 2 6-volt coils I've actually bought for the unit, we're going to wire up in series, and we're going to do exactly the same test just to see how powerful that spark is. I'm going to measure the resistance, the ohms values of all the coils. We'll do a bit of a write-up at the end, put it on a sheet, and we'll just see what's going on. We'll compare it. So let me set up for the next run and see how we go. See you in a short while. Okay, so getting a bit busy down here now. Set a few more things up. So now there's the 2 coils that are going on the bike. The 6-volt coils wired in series. These are the spark plugs out the bike, and the HT leads out the bike. I've got my strobe set up, and I've now got a timing card or a timing disc. So I'll just show you what's going on. So lights off and power him up. So there's our spark. That's 850 engine speed. And that's about 2,800, 2,900 engine speed. We'll bring it back down to idle, and we can just dig in here now, so you can see I've got the pointer on 0, so we're ticking over. So I'm now gonna and you get about 6 degrees from tick over to, I'm gonna say, 2,800 RPM, which would be double that, 12 degrees obviously, because this is travelling at camshaft speed. But this is interesting. So I'm now back down to tick over, and if I just switch off the lathe, just turn the speed down, right down, as if I'm going to kick start it. Right down. It really gives you like another 5 degrees of retardation. So it's definitely, that's why the B50 never kicks back. Look at that for startup. It's quite a good. So if you got a B50 with a 10:1 compression ratio, 500 single, this is going to work for you, well, like it does for me. And then I'm going to go right down on off and then back on again, as if you're kicking it over. And look at that, well retarded, which is quite good. And the other thing what somebody mentioned was that because it goes to sleep after a second or two, so the coils don't overheat. And then this guy said that you need to kick it over like once to wake it up. No way. As soon as I switch this on now and it starts to rotate, it sparks straight away. Off. And this is a very, very low RPM, so what we on there? You're kicking this over about, what, 190 to about 300 RPM kick start speed. And as soon as it spins, it sparks. So it's gone to sleep, turn it, and it comes on straight away. So even though the unit goes to sleep after a second or two, the capacitors must still be charged in the CDI unit, and all you're switching off is the feed to the SRC, you know, the switching gate, the transistor, because the second it goes over one of those ferrous poles, it sparks. So that's why on the B50, you know, I can, if I'm lucky, with getting all the settings right and tickling and holding the carburettor, this twist grip at the right position, it will start first kick. So this thing where after it's gone to sleep you need to, you know, kick it over to wake it up, no chance. It's spontaneous. The second one of those magnets goes over any of the poles, it's away. So I made a bit of a mess here, got a bit of tidying up to do, but after I've done that, we'll be pulling a few bits off the bike, and we'll see how it goes on. So we'll catch you in a quick short time. Catch you later. Okay, so everything's back off the lathe, back on the bench. Just quickly run through a few bits and bobs that might be of interest or be helpful to others in the future. So 12 volts, it's micro Mark 1, so it's for 12 volts. They actually do one Mark 2, I think for 6 and 12. Anyway, this is the one that I've got on the other two bikes than I've fitted before. So if I have any issues, I can always swap things around to see if there's a problem somewhere. So the double block connector goes to the stator or the pickup, and then you've just got the other three wires. And because I'm going negative ground, the red wire positive goes to the positive side of the coil, and I just put my positive feed on there, and the negative goes to the white, and that's it. So there's not a great deal in there. You just have to remember to wire your 6-volt coils in series, so in, out, in, and then this is the negative from the black box, and that's the trigger that's going to go open circuit, collapse the coils and give you the spark. So dependent on the direction of rotation, Triumph twins are clockwise, so anti-clockwise or clockwise. And what I do is get my little square, line it up, and I scribe a line down, because you get like a lot of parallax error when you're looking down there, because it's a big distance from that line to the mark on the rotor. So that makes it a little bit easier. Oh yeah, there's a resistance value for these coils which it gives you in here. So if you can do a manual check if you have an issue. And it gives, if I can see it in here, the resistance of the stator coil should be 73 ohms each. Well, there's no way that you can separate them. You've got to measure them both. So if one coil's open circuit, you're just going to get an open circuit reading there, but you're going to obviously double that, so it's going to be 146 ohms, isn't it? And the other thing to bear in mind, there is a maximum current draw so to the unit, so that hence you can't use the two 12-volt coils because it's pulling it down too much. 12-volt coil was 4 ohms, two of them 8 ohms, too much. But these are, I did write the values down, these are 1.5 ohms. So the original coils on the bike, primary, was 4.5, so that's 9 ohms. There's no way you'll burn the box out. So 2 6 volts, 1.5 ohms, going to give you 3 ohms. So 3 to 4.5 ohms of primary resistance in series, job done. So that is about it really. So what I'm going to do first is I'm just going to drop the coils on. These are 40mm coils, so they should go exactly in place of the other ones. So I'll just set that up ready, throw them on, we'll switch it back on, have a look, and then we'll move on from there. So we'll catch you in a second. So we're on the way, got a few bits on now. So here's the coils fitted. So they're 40mm OD outside diameter, so they're exactly the same as the originals. Now I've got redundant wires, obviously. That's the left and right hand side points on the condenser. So I've put the link in and I've got the feed on, so they're ready to go. Also got the little unit fitted, the CDI unit, capacitive discharge unit, on the little aluminium plate with the Lucas rectifier regulator. And I've just pulled out from the timing case the AR unit and the 6CA point unit. But just as a, so let me get the torch, just Triumph only, if you look in there, if that will pick it up, there's like a little piece of wire, or a little piece of very small diameter bar at the bottom, which the AR unit locates onto. So if you ever pull this off on a Triumph only, it locates and goes back in exactly the same place, and provided you've marked your 60A stator plate, you can take all this off and it'll all go back in exactly the same spot. So what they do is they make the taper on the rotor, the rotating magnets, a lot shorter, so it doesn't pick up. If I can find it. So it doesn't pick up on that notch. So this can now go in anywhere you like. So I'm just about to start to build this up now, and we'll do some rough timing settings, and we'll check a few marks, and we'll see if we can get a spark and get it going. See you in a bit. Okay, just a couple of make life easy tools. So spin the engine over until you get your degrees before top dead centre, the mark there. And this is just, you can buy these I think, or somebody will be selling them on Fleabay for sure. This one is 1/2 inch Whitworth, but the pitch is the same for Whitworth and UNC. This is UNC in this case, but it does screw in, so you take the plug out from down there, drop your locking tool in, so you're going to find the hole in the crankshaft, and that's just dropped into it because I've got it lined up. And then if you just wind the nut in so it keeps everything centralised, that now is locked up in the full advanced position. It doesn't matter whether you've got valves rocking or compression on either cylinder, because the electronic ignition is spark idle. So every time the piston comes up to the top, obviously it's a parallel twin, they both come up together, you're going to get a spark. So you don't need to worry now about number 1 and number 2. They're both going to spark in unison. So marked up, locked up. So we'll just spin round to the other side, he said. And I've had this out once before, because obviously we'd already done the fitment of the little taper on the back, etc, etc. But this thing, the original advanced unit, if I just nip that, I'll just show you the easy way to get it off the taper. So nut, bolt out, and this is just a bit of, I don't know whether it's a bit of 6mm or something, 55mm long. Throw that in there, and you need, for this particular version, I don't know whether there is any cycle thread versions of this, but this one is 5/16 UNF, Unified National Fine. So that now is butting up onto that bit of steel. Get the right size, which isn't that one. And if you just keep going, eventually it'll jack it off the taper. There we go. So that's how that comes out. And like we said, the fantastic idea with the little notch and the little peg in there is great, because it can only go back in the right place every time if you ever want to revert back. So here's our rotor, rotating magnets, and this one, in this particular case, you get 3 Allen screws in the kit. So the big one is just the pushing one for jacking this off if you need to take it off or move it into a different position, and the other two, dependent on whether it's BSA, Triumph and what year, you've got UNF, quarter UNF and quarter BSF. So if you get your pulling bolt, wherever I've put it, you can identify, and that's not it, the thread, and in this case it's this one, which is quarter BSF. So now this goes in anyway, and I'm just going to put those level for the moment, and then we lock it up with this. Have I got the appropriate Allen key? Yes, I have. I just want to show you the removal, etc, etc. So say if you get it in whatever position you think, we'll do this in a second. I'm going to set up a bit further on. Lock it up, and if you need to move it, spin out your securing Allen key, and I think this one just looks like 5/16 metric. Wind that in till it bottoms out, and with the appropriate Allen key, which is that one, I'm just now pushing in the bottom of that taper, and it should jump it off, he said. It's tight. Just let me have a look at that. I've had this in and out once before. I may end up, because what it's doing, it's pushing in the bottom of the taper, and I can feel it folding the threads over, yeah, but that jacks it off. So, and that's that in and out. But obviously for setting up, you don't need to wind it in dead tight. Wind it in so it's just binding until you set your adjustments. And I'm going to grind a little lead on the front of this pushing Allen key, Allen bolt, because it's actually catching in the bottom of the taper there and gnarling it up a bit. So there's our locking devices. So then let me just set a few more things up and we'll get a few basic settings done. So we'll catch you in a second. Okay, bit of an update on this. Not looking good, bit of a design issue, but this is in and it's tight. So slack him off without dropping the Allen key. So it's now locked on the taper. But to get this out, only on a Triumph, not on a Beezer, because we haven't got that little tang in the bottom. But when you wind this in, the screw actually catches, the threads catch on that little pin which is in the bottom of the taper that locates on our little friend here. So you cannot use this bolt. So what I've done is, this is a bit of 4.5mm or a bit of barb which will pass, which is smaller than your quarter holding bolt, so you're not damaging the threads inside. And I've just drilled into the bolt a little bit and put this in. So you need it to stick out by 25mm. And then what happens now is when you wind this in, it doesn't, the fat bolt doesn't go all the way down to the taper and it's off already. So you're not using the thread that's going to get caught on our little friend inside there, that little piece of piano wire or whatever it is. So that really needs to be written into the instructions. I mean, things like it would be nice for them to tell you that the reason the taper on this is so short is to actually miss that pin. But then they give you this bolt which is going to rip itself to death on the edge of that hardened bit of piano wire. But anyway, just make sure that you don't get hung up like I have. Obviously on a BSA, not a problem. Maybe not on all Triumphs, but and they give you this to like, I don't know, get a couple of screws with it so you can adjust it, but I won't be using that. But anyway, moving on. So we'll be back in a short while. Okay, these are some rough start points. So there's our little mark or line on the opposite the magnets. So I've actually got it facing, there's 2 screws in each. I've got it facing the forward screw, so the one which is to this side, those 2 are the ones for the starter plate. I'm not really sure what the other 2 are for, but anyway, line this up on the forward one and then just nip this enough so you can still maybe turn it, but you can still play around without having to break it back off the taper. Let's drop our stator on. So stator goes in, and I'm just going to loosely put one of these in. So I've got that now in the middle of the vernier slot. I'm just going to release you from here. If we can use the torch, you might be able to catch that. But that gives you your alignment for C, for clockwise rotation. So I'm in the centre of the vernier adjustment slots, so I should be able, as a start point, to statically time this. So that's a good start point. So what's that, maybe 5 degrees beyond that first screw, so it picks up on that second screw hole, whatever it's for, and then this in the centre of the vernier slot gives you your alignment for your clockwise. So let's see how we go from there. So we'll be back in a short while. Okay, we're in, we're done, we fitted. The wiring is just hanging in there. A couple of reasons why. You have to file a little half moon in the stator to get the wires through with the insulation on. I'm going to end up soldering these and shrink wrapping them, etc, etc, because there's no way you can do anything else there. What I've done on these machines, on the B25, same setup, what I've put in here, I fit this big domed points cover. There's a lot of space on the inside, and I fit a 2-pole connector in there so you can unplug it and take it away, because originally the wires went back behind and you had to make the join inside this case, and obviously I'm not going to have a joint inside a case where I can't see anything, and I had to do the same with the B50. Originally, you can see here the wires went in from the top, so obviously any water that got in there was going to get in from the top and stay in there. So I've done the same with this one. So you file a half moon in this casing, you put a tail grommet in there to make the seal, and you bring the wire out and around. But I don't want to have the wire sticking out on this one. I want to use that hole going through the inner and the outer timing case, so hence I'm gonna solder those and shrink wrap them, and they'll go up when we make the new wiring harness with the oil pressure switch wiring. So I've actually run it, did start second or third kick, should start first kick. Now it's warm. Oh, it's barely warm. So I'm set up with a strobe, and I'll just show you what it looks like. I'll just put you down for a second. So don't need any choke. This is warm-ish. I might just give it a couple of blips. Okay. Let go. So we could say it's a success, and for those of you, or those guys who was looking on another YouTube video or on the internet somewhere, that said that you know, you'd have to turn the, once it's gone to sleep, the unit, after a couple of seconds, you have to like kick it over to wake it up, then it'll start. I mean, that's not true. I mean, obviously, you know, if we get things right with these, you know, choke, etc., you know, amount of throttle, they start first kick, and they're only singles, and you've just seen this thing start first kick. So I'm hoping it's going to be good. So the test is, there's a hill, Harris Hill, not too far away from here, and I should be able to go up it in third gear. If I leave it in third, it'll go up, but it pinks like mad. So I have to drop down to second, because I think the springs or whatever, the bob weights, are worn in the AR unit. So the test will be, well, you can see the advance curve, you can see it, you know, moving, and it obviously doesn't kick back. So I'm hoping that's going to be spot on, and when I do my trip up Harris Hill in third gear, it doesn't pink. So hopefully that bit is done. So the last bit now for the bike before it's finished, and I'm going to be my daily ride or whatever, I'm going to make this new wiring harness for it. The wiring's very untidy. I have replaced a few bits and pieces where, you know, the insulation's gone hard, brittle and cracked, but I'm not sure what's going on up the spine. I've got live feeds everywhere crossing over, so the lot's coming out. I've already done like a basic hand drawing. I'm going to draw it up in CAD before I make the harness, but that'll be the next vid. Will be designing, making and fitting the new harness, and then hopefully, you know, I've still kept the Zener diode on it so it looks like original. I'm still going to keep the two little coil capacitors, condensers on there so it looks original, so you know, nobody knows it's got an electronic rectifier regulator, and nobody would know that it's got a, you know, electronic ignition unless you started to take things off. So that's where I'd like it to be. So I'm happy, and we'll catch you on the wiring job on the next one. See you later, folks. Thanks.